one of the things that we have to think about is, what are we trying to do? One of the big problems I always see is growers just do stuff and then try to figure out how to fix their problems. So let's step back a minute and say, okay, what kind of tools should we be really having available to us? What should be in our greenhouses to actually make it work? So, one of the first things that we know is that if you're rooting cuttings, you're getting this unrooted cutting that has, of course, no roots. And if it has no roots, it has no way of taking up water. And when plants can't take up water, they wilt. I mean, this is really pretty straightforward and very, very simple. So one of your first responsibilities as a person that's rooting is to keep that cutting hydrated. How do you get a cutting hydrated? Well, as you get water in the air, so you get high relative humidity, you can basically and you can do that by putting on different mist systems. So Keith, what kind of mist systems do we have today to actually kind of solve some of these problems?
Yeah, so there's different types of mist out there, and so with that you get a lot of different nozzles that you'd have to use. And so this is a small example of a mist system nozzle, and it's a very fine mist, because we really measure everything by the droplet size, how much it's going to put out, how fine of a mist, how often, and different types of filters. This one has a little small filter on the bottom of it. So we want to make sure that whatever type of plants that you're propagating, you want to make sure that you have the mist that goes according to it. So other mist nozzles, they can be a little bit different. If I can get this off the end, they might have different heads so that they can disperse it. So if you're going across a different size bench that you may have, or if you're trying to put an output, more specific to the style of flats that you grow, or the different plants that you grow, some of them don't need as large of a droplet size, because what you'll find out is, this type of year where a lot of people are growing their spring annuals, but it may be different from when they do mums, poinsettias, anything like that. You may need a different type of mist. Not all one is the same.
Right.
And so that brings us into more like with the control aspect. Everybody has some kind of sort of controller. This Rainbird controller here can be set up for different zones and stuff like that. But you really have to know what kind of plants you're growing, because like you might have different mist settings, different light, which we'll get into later and stuff like that. But something simple as this might be all you need for your depending on how size of your operation is. So you can go in here and like today here it's raining. We might not need as much mist, so we're going to do different types of sensors and stuff like that to
well, and on top of it, here today in Cincinnati, we're in January, and the temperatures have basically gone up to like 50 degrees, which is like all-time high temperature for the and of course when you have that, then you end up with fog, and that is the ultimate mist. Fog is the ultimate mist, which is kind of what is really nice about that one nozzle that you told us. Which has a really fine, super fine. It just doesn't put a lot of water out, but it puts a lot of water in the air, so that you end up with a fog, and that basically allows the plants to absorb a lot of moisture. And so it's really important to have that fog, especially early on, because where you're sticking your cuttings is dry.
Right.
And you know how you can tell it's dry? Check your floors. If your floors are nice, shiny, gray concrete, guess what? It's sucking the water out of that air, drying those cuttings out.
Right.
And so making sure that you're, you may want to have a fog system in your sticking area, just to make sure that you're not drying those cuttings out while you're waiting to get them all stuck to be moving them to the greenhouse area. So it's really important that you really think about, is that environment, and how does that interact with your controller?
Correct. Yeah, because you might only be putting so much water out. I mean, you would think you're putting volumes of water out onto your cuttings, but in reality, you're not putting very much water out at all.
With the fog.
With the fog. Yeah.
Right. But when you get some of those older nozzles that were around, even as recent as 10 years ago, they can put out a phenomenal amount of water. And basically, you end up with saturated trays. And I remember one grower that I was dealing with, they couldn't figure out why everyone else was rooting their cuttings in like 4 or 5 weeks, and they were at 6, 7, 8 weeks long. So I went and I visited them, and I went and I picked up a tray, and I thought I was going to kill myself. That tray must have weighed probably about 6 or 7 pounds instead of about a pound, pound and a half. And it was only because they used the wrong nozzle. And when they turned that nozzle on, they basically flooded that whole area because they used the wrong kind of nozzle. They used the wrong controller. They didn't really sit down and integrate their nozzles to their controllers. So let's talk a little bit about that controller, because I think that's really important as to what you can do with this.
Yeah, so these different types of controllers, I mean, you can have a lot of, it's funny because I'll go into some operations and I'll see a lot of them, they have them on manual, you know, and it's you're like, why are you operating manually? Are you having somebody come up to it every, you know, half hour, 30 minutes, 40 minutes, and just, you know, pushing it and running it for 2 minutes? It's not optimal. It's
Right.
definitely not optimal. And if you've got the correct sensors and you use the, you know, the different settings that these things are capable of, you can really get that misdialed into whatever plant that you're propagating at the time, you know. So like right now we're seeing a lot of like lantanas and geraniums and
Right.
eugenes and stuff like that. But you can also, you know, hook this thing up to your weather system. So, you know, if it is sunny day, it can increase its amount of water that's going onto your plants. Or if today, like we were saying, it's 55 and rainy, you could decrease it so that it's not coming on as often. So that's all kinds of things, that different controllers. Now this one's probably really basic, right? You know,
Right.
it's just a basic controller. But as you get into the heavier duty, like the mist systems that you can go out there, you know, it can have water sensors, it can have leaf sensors, it can have humidity sensors, light sensors, the whole 9 yards, which really can run your propagation area pretty effectively,
Right.
based off what the grower wants to input. So, but other than that, you know, this one here has seasonal adjust. You know, you see these type of controllers can be used in the lawns too. But I do go into operations that use these Rainbird controllers because they work great.
Yeah, and you know, it's about thinking about what you're trying to do, because there's two concepts that you have to keep straight and not confuse when you're using it. One is, how long is it on? That's the on cycle. The on cycle should be enough to basically get the cuttings damp, not soaked, just damp, just get it on. And of course, if you don't design your system, that's why you really need to talk to someone who's actually engineering your system, so that you don't end up with, 300 feet and a valve at the very end,
Right.
and it takes about 5 minutes to basically energize the entire line.
Right. And that's a good point too. You know, talk about energizing the whole line. A lot of things that I don't, when I go into these operations now, a lot of people don't have pressure compensating heads.
Oh, yeah.
And what I mean by that is, wherever your water source is coming in, you know, you're going to have full on pressure, whatever your pressure is, and all the way at the other end of the line, it's just spitting out. Yeah. And I see that so often where people don't even look at that, and they don't. If they had pressure compensators all the way down from the very end to the beginning, it's going to be the same pressure across it.
Right.
But even further than that, we get into filtration. And a lot of people ask me all the time, do I need filtration? And the short answer is yes. You don't realize, I mean, there's so many different water sources that you can have. Municipality, you can pull from a well, you can pull from a pond, you could be pulling, you can have reverse osmosis systems, you can have all kinds of things. You're going to need a filter regardless. And that's going to be highly important to like what you want to put through that mist system, because the last thing you need is a little chunk of calcium or something like that clogging up your line. And one thing to check is a really good, I got a whole pile here of fun stuff. You might have TDS and pH and EC sensors, and you might have different types of thermal things, and you know, the classic HANA kit that every grower should have in their wheelhouse and stuff like that. And you really should test to find out what kind of water you're putting into your thing. If you're going in gung ho, you've already done it wrong.
Right.
Yeah.
Well, and the other part that all of these are great because they tell you the quality of the water that you're starting with. But the sleeper is the biofilm. Now, what is biofilm? Biofilm is the crud that's inside that pipe. Okay, simple as that. And biofilm will form in the nicest of greenhouses. And it's what it is it's basically it's the bacteria and the algae that forms inside your pipe, kind of like it's a membrane, so it's inside. And it basically, what happens is, if you have white pipes, do you have any white pipes in your greenhouse? Probably. Back in the olden days when we had all steel pipe, we didn't really talk about biofilm because it was perfectly dark, you didn't grow anything. But if you have white pipe and if you don't have, if you have any cracks or anything, you're going to get stuff in there, and it's going to slowly start growing. And then all of a sudden you get a surge in there, and what happens is you delaminate that, you basically break it off. Think of it as you're peeling off the inside of your pipes. And if you don't have filtration along the way, what's going to happen is all that biofilm is going to end up somewhere, and then where it's going to end up is at the end of that nozzle, and plug it up so that it might not necessarily, and this is always scary to do, is you're going to measure how much water is coming out of each of those cups, each of those nozzles. So what we do is we put a cup underneath each one of them, just kind of for chuckles, see what happens. And that is a scary thing.
Oh yeah.
Because if you put hang a little cup underneath each of your nozzles and then just turn it on for a fixed amount of time and then line them up, what you should have is they should all be exactly the same amount, right? And what do we normally see?
It looks like a step.
Yeah. Or you get this up and down, and you basically say, oh, well, that's a bad one.
Right.
And of course, what happens is that you end up with very ununiform cuttings. You have cuttings that don't root. You have cuttings that don't have good root growth. You've got saturated soil. You've got, I think, what they refer to as a mess.
It's a mess. I mean, what can the biofilm? I mean, it's true. What can the biofilm do to your rooted cuttings too?
Well, have you ever had algae in your greenhouse?
Oh.
Because it is a form of algae, and it is, you can get all kinds of technical stuff, but it is the stuff that gets the algae going. And once you start putting a lot of water, you get algae growing, and then you get crust, and that crust then prevents the water from moving through and the fertilizer through, and then you end up with a bigger mess. So if you're a grower that you see, one, it's slippery in there. That's kind of like a klaxon horn of maybe we should get some filters, or better yet, should we check the filters to see if they're plugged?
Plugged.
Yeah. If you're seeing that you have a lot of algae, instead of going after some chemicals, go after some filters, because filters will take a lot of that out, if not all of it, depending upon the type of filtration you have.
Right, and it's important to know it can happen with any water source.
Right. Yes.
Municipal water sources, even though it might have fluoride or something like that in it, you can still get biofilm in your pipe.
Oh yeah, that's the biofilm. The only way that you can really clear biofilm out is you can add something to the water system. You can either use a hydrogen peroxide, which can be a little tricky to use, but can be injected. You can inject chlorine, but that also is very specific. You got to be monitoring it, or else you basically nuke plants and kill plants with it. But so there are things that you can do to eliminate the biofilm. But at the end of the day, you need to make sure that you've got clean water coming through that nozzle, right, and that filtered water. So whether it's the chemical content, which of course the various equipment will tell you whether you've got hard water, high pH, low pH, whatever. EC, that you've got something wrong with your water that you're using, but you also have to deal with biofilm, and that's what the filtration really does do a job.
Right, and it's important. It's very important.
Yeah.